having video lectures throughout the term, no? And this specific video is the final part of series of topics regarding the soil bearing capacity, no? So from if you have any questions, don't hesitate to comment, no? To leave a comment below, no? Or try to message me through Blackboard, no? Or through Facebook Messenger, no? Or the rest of my social media account, no? So this part of the lecture, no, is specific to factor of safety and allowable bearing capacity. No? So regarding the factor of safety, no, we are already familiar with the term ever since we took, no, engineering mechanics courses. No? So simula pa lang strength of materials, no, uh, matunog na yung factor of safety na yan. No? Pero what is the concept of factor of safety? No? So let me give you a little example. No? For instance, no, let's assume that this is a cable. No? And as we all know, na cable, no, can break, no? So masisira to, no? Rather, no? Let's say when we apply tensile force, no, on this cable, no, it will continually induce stress, no, until a certain point na masisira siya, no? So ngayon, ang goal natin as designers, no, is our structure should not reach that limit, no? Kaya ngayon, ang ginagawa natin, we are going to set yung allowable stress, no, na pwedeng i-induce yung material natin, or in this case, yung structure natin, no? So on siguro similarly, no, parang we are setting a budget, no, kung ano ang capacity na ano ang nararapat na capacity no structure na balak natin i-design, no? And in this case, we are going to incorporate factor of safety, no, on the shallow foundations, no, that primarily cause bearing capacity failure. No? So let's proceed. Yeah, so for my students, no, I already uploaded this set of notes on your Blackboard, no, but I'm going to show it here, no. So in the case of soils, no, dahil unpredictable siya in nature, we tend to use greater values for the factor of safety, no. So in this case, we use a very conservative value of 3. Pero most of the time, no, some practitioners tend to lower their factor of safety hanggang 2, no? So technically, the minimum value for factor of safety is 2, no? Pero of course, I cannot personally recommend that, no? So we just use the 3, no, as our guide, no. And ngayon, pag nag-set na tayo ng factor of safety natin, we will be able to derive 2 types of allowable bearing capacity, no. So the first one is the gross allowable bearing capacity, no. So this is the gross allowable bearing capacity, the first bullet, no, the Q allowable is equal to the Q ultimate over the factor of safety, no? So yung Q ult natin, no, ito yung formula natin from our previous lectures, no? So I would rather not try to elaborate that, no? So next, our net allowable bearing capacity, no? So saan natin nakuha to, tung net allowable bearing capacity, no? So let me explain that further, no? So if you can see from this figure, no, we know that the bearing failure of soil tend to happen underneath this region, which is the base of your footing, no? So nakikita nyo sa figure natin na ang bearing failure, no, let's say this is your footing na, no, this is your footing being subjected to a certain load, no, na kailangan niyang i-withstand, no? So from the figure, no, we know that the load from the column shall be transferred on this footing, no, on this region. And then, no, of course, yung load na galing sa footing natin shall be transferred on your soil, no? And of course, bearing capacity failure tends to happen under your footing, no? So therefore, of course, so therefore we are considering, no, every load that no, na posibleng mag-cause ng bearing capacity failure, no? Pero of course, dahil alam natin na kapag ginawa na natin yung footing, no, pag ginawa na natin yung footing, we are going to remove, of course, we are going to remove the soil here, no? We are going to remove the soil here, no? 'Di ba? Kapag gagawin na natin yung footing na to, we are going to excavate the soil, no? So let me highlight that one, no? So this one, no? We are going to remove all the soil within that region, no? So therefore, no, we can be able to neglect, no, the stresses that happens above the footing, no, as, no, so therefore the stress, no, that is located, no, the stress or the, let's say, the overburden pressure above that base of the footing can be considered negligible, no? Kaya ibabawas natin siya from the computation of your bearing capacity. So ngayon, the net allowable bearing capacity will now become your Q alt minus your Q, no? So your Q here is equal to your gamma dF, no? So over your factor of safety, no? So that is a concept that we just need, no, when it comes to factor of safety, no? And now let's proceed to solve some sample problems, no? So, no? This is the complete version of the sample problem that we are already solving from the previous lecture videos, no? So a square footing is 1.5 by 1.5 meter in plan. The soil supporting the foundation has a friction angle of phi is equal to 20 degrees and a cohesion of C is equal to 15 kilopascal. The unit weight of soil is 17.8 kilonewton per meter cube. Determine the allowable gross load on the footing, no, with a factor of safety of 4.00. No, assume that the depth of the footing is 1 meter and that general shear failure occurs in soil. No, so let's draw the figure first. No, uh, let me put the let me put it there. No? Okay. Let's write sample problem 1. Sample problem 1. No? Okay, that is your sample problem 1. No? Let's draw your footing. No? So this is your footing. This is 1.5 by 1.5 meter. And then this is your soil, no? Okay, and the depth is 1 meter, no? So let's say that they are not on scale, no? Okay, no? Your gamma, your unit weight is equal to 17.8 kilonewton per meter cube. Okay, your C is equal to 15 kilopascal, and then your phi is equal to 20 degrees. No, okay, no, determine the allowable gross load on the footing with a factor of safety of 4. No, so we are going to determine your Q allowable gross, no? So this is equal to your Q alt over the factor of safety, no? So let's say your Q alt over 4, no? And the formula for your Q alt, no, let's recap that, no? So Q alt is equal to, no, 1.3, no, C NC plus Q NQ plus 0.4 gamma B and gamma, no? So I think I am right naman, no? So I'll balikan ko lang ng konti yung notes. Oh, and that's right, no? And we are able to derive that the values for NC, NQ, and N gamma from your angle of friction are the following, no? So ang values natin for general shear failure, no, are NC is equal to 17.69, no? NQ is equal to 7.44, no? N gamma is equal to 3.64. Okay, no? And now your Q, Q is the overburden pressure at the base of the footing, which is equal to gamma, which is equal to 17.8, and dF, which is equal to 1 meter. Okay, now your Q alt now will become 1.3, C 15 multiplied by 17.69 plus 17.8 times 1 times 7.44 plus 0.4, 17.8, 1.5 B, and gamma, which is equal to 3.64. Okay, so we are able to solve for Q alt as 1.3, 15 times 17.69 plus 17.8 times 1 times 7.44 plus 0.4 times 17.8, 1.5, 3.64. That is equal to approximately 516.26 kilopascal. And by that, your Q allowable gross is equal to 516.26 over 4, which is approximately equal to, let's just divide it by 4, which is equal to 129.07 kilopascal. Okay, for going back to the problem again, so if the groundwater table is located 1 meter below the bottom of the footing, determine the allowable gross load per unit area with Fs is equal to 3.00. Assume that your gamma sat is equal to 19 kilonewton per meter cube. Okay, so letter B now. Let's draw your footing first. Okay, that this is 1.5. So this is your footing now. This is 1 meter. And your groundwater table is located at another 1 meter. So this one. Okay, so this is your NGL and this is your groundwater table. So we know that your Q, your overburden pressure is still the same. This will become 17.8 multiplied by 1.00. And but the gamma that we're going to use shall be approximated as the average gamma. And the formula for that, from our previous discussion, is equal to, that's the case. Ang case kasi natin, the depth of the groundwater table, below the footing is less than the base of the footing. So your D is less than B. So is equal to 1 over 1.5 multiplied by, that is 17.8 times 1 plus 17.8, the gamma sat is equal to 19. 19 minus 9.81, 1.5 minus 1. Okay, and we are able to approximate your gamma average, so 1 over 1.5 times 17.8 plus 19 minus 9.81 multiplied by 1.5 minus 1, approximately equal to 14.93 kilonewton per meter cube, and by that we are able to approximate your Q alt, so we are able to approximate your Q alt as 1.3 times 15 times 17.69 plus 17.8 times 7.44 plus 0.4 multiplied by 14.93 B, which is equal to 1.5, and gamma 3.64. Placing that on the calculator, 1.3 times 15 times 17.69 plus 17.8 times 7.44 plus 0.4 multiplied by 14.93, 93 multiplied by 1.5 is 3.64. That is approximately equal to, Q alt is approximately equal to 509, 509.99 kilopascal. But we are going to divide it by 3, because we assume that your factor of safety is 3, so therefore your Q allowable will now become gross is equal to 169.99 kilopascal. So if you want to approximate for the net allowable bearing capacity both of these values, so we just reduce your Q, so Q allowable, going back to your A, Q allowable net, which is equal to 516.26 minus 17.8 over 4. And for the second part, Q allowable, let's write it here. Q allowable net is equal to 509.99 minus 17.8 over 3. So let's calculate both of them. 516.26 minus 17.8 over 4. That will become 124.62 kilopascal. And then the other one will become Q allowable net is equal to 509.99 minus 17.8 over 3. This is approximately equal to 164.06 kilopascal. Okay, so that is an example for factor of safety and allowable bearing capacity, no? So we are going to solve uh, another problem, no? Because the next problem is somewhat related to our next topic, which is designing shallow foundations, no? Particularly isolated footings, no? So let's give space for the next problem, no? And we're going to read your next problem here. Okay? No? A square footing shown carry a gross mass of 30,000 kilogram using a factor of safety of 3.00. Determine the size of the footing, no? So this is a sample problem. This is somewhat an example of uh, how to approximate uh, the size of the footing that we need, no? So because when designing shallow foundations, no, we design the depth based on, of course, yung bearing capacity na kayang i-withstand nung footing na yon. And of course, pag nilakihan natin yung footing natin, no, it reduces the bearing capacity failure, the risk of bearing capacity failure, no? So let's solve this problem, no? Okay, yeah, let's draw your footing here. This is sample problem 2, no? And we draw it on this manner, no? The load is equal to 30,000 kilograms. Okay, and then the other data, no? The depth is equal to 1 meter. Okay, your rho, or the density, is equal to 1,850 kilogram per meter cube. Your C is equal to 0, and then your phi is equal to 35 degrees, no? So we are going to approximate the base of the footing, no? Other data pala, no? Factor of safety is equal to 3.00. Okay, no? Of course, we need to solve first for the ultimate bearing capacity, no? We are going to approximate it, no, using the formula, no? O nga pala, no, we can assume that we can assume that this is a square footing. Assume square footing. Okay, now the formula now for Q alt is equal to 1.3 C NC plus Q NQ plus 0.4 gamma B and gamma, no? So that is the formula, no? And you know that here C is equal to 0, so this shall be cancelled out, and you can again refer to the tables that I gave you, no? So your NQ and N gamma will be, if your phi is equal to 35 degrees, no, 41.44 for NQ, and for N gamma, 45.41. Okay, no? Yan. Okay, no? So your Q now, no, is gamma dF. So let's approximate this first, no, for simplicity, no. You know that your force here is written in kilogram, no. So let's convert it into kilonewton, no. We can also convert this one into kilonewton, or might as well just use it as it is, no. uh, we can just use it as it is, no. um, okay, or much better, no, for in order to not confuse you, we can just convert this into kilonewton per meter cube, no. So we know that uh, if we multiply this by 9.81, this will become newton. Pero of course, in order for it to become kilonewton, we divide it by 1000, no. So therefore this will become 1850 times 9.81 over 1000. This is equal to 18.1485 kilonewton per meter cube. Okay, no? Then your 30,000 kilogram, no, can by using the same process, no, will become 294.3 kilonewton. Okay, no? So by that, we can be able to approximate your Q, no, by 18.1485 multiplied by 1 meter, no, times your NQ, which is equal to 41.44 plus 0.4 gamma 18.1485 B, no. So we don't know the value of your B, no. So B times N gamma, which is equal to 45.41. Okay, no. So your Q alt will become, no, Q alt now will become 18.1485 times 1 times 41.44. This is approximately equal to 752.07384 plus 0.4 times 18.1485, no, times 45.41. This will become 329.649,354 B. No, this is in terms of B because we don't know the value of B yet, no. So that is your Q alt, no. Okay, and then, no, so we assume, no, so now going back from here, no, we know that the load that is acting on your footing, no, can be associated as the one that will cause your bearing capacity failure, no. So we can assume that this load, no, will become your allowable bearing capacity. And there are two types of uh, allowable bearing capacity. No? So the first one is your uh, gross allowable bearing capacity, Q allowable, no, for gross is equal to Q alt over your factor of safety. Next is your Q allowable for your net, which is equal to Q alt minus Q over your factor of safety, no? But which allowable bearing capacity, no, are we going to use, no? So we can try the both of them, no? So if you are going to use the gross, no, if we are going to assume that this load is the gross allowable bearing capacity, no, so 294.3 over, we assume that this is a square footing, no, so therefore your area is equal to b squared, no, equal to, no, q alt 752, is equal to 752.07384 plus 329.649354b, no, over 3. Okay, no, so we can just re-express your equation. 294.3 times 3 is equal to 882.9 equal to 752.07384 b squared plus 329.649,354 b. Okay, so if we transfer it on the other side, no, so 752.07384 b squared, no, plus 329.649, no, 354 b cube minus 882.9 is equal to 0. And now, so we can be able to solve for the value of b, no. So in my case, I'm going to use the mode 5 from the calculator, no. So mode 5, no, so nakikita nyo dito na what I'm going to use is the cubic equation ax cubed plus bx squared plus cx plus d is equal to 0, no. So we're going to input these values, no. 329.649,354, no. 752.07384 0 negative 882.9, and we have three possible values for b. Three possible values of b, no. First is 0.992, no, so meters. B is also, no, the other values of b are complex numbers, no. So the most possible value of b, no, is 0.92, but of course we should round it up. We can say that this is equal to 1 meter. Okay. Next, this value is when we're going to use the gross allowable bearing capacity. If we're going to use now your net allowable bearing capacity, if we're going to assume that this is the net allowable bearing capacity, no? So let's try it. 294.3 over b squared is equal to, no, 752.07384 plus 329.649.354b, no, and minus your q, no, minus 18.1485 18.1485 over 3. We rewrite the equations again, no? So we're going to rewrite the equations again. Okay, so 294.3, this will become 882.9, no? 752.07384 minus 18.1485. Now this will become 733 733.92 92534 plus 329.649.354. This is over 3. I know. Correction. So we delete this one and we all multiply this by b squared. So 882.9. Rather, we rewrite it as a cubic equation. This will become 0 is equal to 329.649354 b cubed plus 733.92534 b squared minus 882.9. We use the same function again from the previous one, no? So 329.649.354 733.92534, no? 0 negative 882.9, and the only value for so okay, so the possible values for B is equal to possible value of B is equal to R, 0.92 meters. Almost the same as when we use the gross allowable bearing capacity. Possible value of possible dimension of footing to the nearest meter, so this will become 1 meter. Okay, and that's it for sample problem number 2. So and that ends our video lecture. If you have any questions, don't hesitate to ask, by again either leaving comments below, no, regarding the topic, no, or messaging me to Blackboard or my other social media accounts, no. And again, no, watch out for uh, announcements kung may ipapagawa akong activity, no, since we are going online, no, for the rest of the term, no. But don't worry for the others, no. Lalo na yung mga students na medyo nahihirapan due to internet access. I'm going to make it as flexible, no, as possible for you, no. And since meron ding guidelines na binigay si Academic Affairs regarding that, no. And if you're just watching, no, hindi kita student, no, you you can still, no, approach me, no, if you have any questions. Okay? No? So thank you very much, no, and see you next video.